Okay, continuing on with chapter 4. You should have done the 4.2 worksheet, which had a lot to do with SOHCAHTOA, 30, 60, 90s, 45, 45, 90s, and now we'll just continue on with some of that. That should make doing the homework problems a little bit easier. Starting off with an example like this, secant is equal to 6/5. So we need to remember that the sine is the reciprocal of the cosecant. These are things that should be committed to memory. Cosine is the reciprocal of the secant, and the tangent of theta is the reciprocal of the cotangent. And then all the vice versas work, so we know that the secant is the reciprocal of the cosine. So in our SOHCAHTOA, so if we're talking SOHCAHTOA, we can go ahead and say, and we can make a triangle. And my triangle will have an angle theta. And my secant, which I will go with cosine down here. Cosine is adjacent over hypotenuse, and that means that if the secant is 6/5, that would mean the cosine would be 5/6. So we are allowed to flip them over. If the secant is 6/5, the cosine, and now I just go off my ka. Adjacent is 5, hypotenuse is 6. We can use the Pythagorean theorem and find this guy over here. And if we call that, I don't know, maybe that's A. So I'm going to have, A squared plus 5 squared equals 6 squared. A squared plus 25 is 36. A squared is 11. And when I square root, since we are dealing with distances on a triangle, I do not need to worry about plus and minus. So this is the square root of 11. Now I could find anything and everything that I so chose. I could find that the sine of the angle is going to be opposite over hypotenuse, and the cosine is we already did the cosine. But if they ask you to find them all, then we should do it. And the tangent is the opposite over the adjacent. And then I can flip them all over and say the cosecant would be 6 over root 11. And really what I was looking for was the cotangent, which was 5 over root 11. That would be exact form. Please remember that 5 over the square root of 11, if you were on a multiple choice test, that has an irrational number in the denominator. We may need to rationalize the denominator, which means I multiply the top and the bottom by the square root of 11. And I get 5 root 11 over 11. I would accept this answer, and I would accept this answer. I would not accept the decimal equivalent. So please make note. Good stuff. Good stuff. Evaluate with your calculator. I'd like to point out on the old calculator a couple of things. Number one, this one right here is clearly the tangent of 8 degrees. Go into your calculator. Go to mode. Check to see, are you in degrees or radians? Whichever one is highlighted, that's the one you're in. Check that now. because this problem of tangent of 8 degrees, you can just type that in. I make sure I'm in degrees, and then I type in tangent of 8 degrees. What you're telling me is 0.1405, said 4 places. That means that if I had a triangle with an 8-degree angle, the opposite over the adjacent would simplify to 0.1405. This one is in radians. There's no degree symbol. So I need to make sure that my calculator changes over to radians, and then I'm going to do tangent of 1.2, and I get 2.572. I guess would be another 2 if I was going to round to 4 decimal places. So you really got to focus on, am I in degrees or am I in radians, okay? Also, when you go to physics or you go to another class and you got to use a calculator if you have a degrees, please make sure that you check that specifically on ACT or anything like that. Second problem, first thing you should identify is that this is clearly in radians, so I'm still there from this guy, but I got no secant key. Okay, what I need to remember is that the secant is equal to 1 over the, which one? Cosine, right? So I can really do the secant of 1.2 is 1 divided by the cosine of 1.2. That's what I type into my calculator. 1 divided by cosine 1.2. I'm in radians, and I get 2.75907. Please make sure that you check your mode, degrees and radians. Degrees and radians. Evaluate without a calculator. Oh no, what am I going to do? Anytime you have an exact value, you're going to be looking for your 30, 60, 90s and your 45, 45, 90s. If you do not have these ones committed to memory, 30, 60, 1, 2, square root 3. Remember, the 30 is always across from the 1. Square root of 3 is 1.7. 2 is always along the side. 45, 45, 90. 1, 1, whoa, 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 1. Square root 2. Go over here, pi over 4. I don't remember what pi over 4 is. I remember pi is 180. I don't have a calculator. This could come up on a no calculator quiz. What a great idea. Pi over 2, 90. Oh, half of that, pi over 4, 45. Just knowing how to divide by 2 tells me that I'm looking for the tangent of a 45-degree angle, which means I'm on this triangle. So this is in radians when I'm not using my calculator because it says do it without a calculator, which could come up on a test or quiz coming up shortly. Tangent, opposite over adjacent. 1. That's it. Check it on your calculator if you're not sure. Whoa, 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 it said without a calculator. It's true. Toa. Got to remember SOHCAHTOA. 6 pi over 6. I don't remember. Well, how do we do that? Pi over 6. I'm in radians. I need to get rid of radians. I need to end in degrees. So really I'm doing 180 divided by 6, which is 30. I'm doing cosine of 30. So go stand here and think ka 30, adjacent over hypotenuse. Square root 3 over 2. There you go. Exact values, no decimals. And so if you put 0.866, because that's what your calculator says, you get it wrong because you got to follow directions. Probably something to note for the test. Important. See if you can do that one on your own. Oh, wait. Sine. Whoa, what do we get? Holy cow. I don't know what to do without a calculator. They're giving me the ratio, and I need a sine. What do I know? I don't know anything. My mind has gone blank. What should I do? I've got the following. I've got SOHCAHTOA, opposite over hypotenuse. Hey, where have I seen square root 3's? Oh, look at here. 1, 2, square root 3. Oh, which angle has an opposite over hypotenuse? Oh my gosh. It would be the sine of 60 equals square root 3 over 2. Therefore, theta is 60. Well, look at that. We can just look at the triangle over here and say, well, I can tell I would be standing up here, standing on a corner of a triangle. Set opposite over hypotenuse. I get square root 3 over 2. Isn't that great? It's good stuff. And then, how do you do that on your calculator? Now, they told me to do this one without a calculator. Let's say we ended up with this. Sine of theta equals, let's say it was 0.12. How would you do that? Remember, you got to do theta equals the inverse sine 0.12. Remember, that undoes it. So now, if I wanted my answer in degrees, I would have to make sure that I put my calculator back in degrees. But I can do the inverse sine of 0.12. Now, maybe you're thinking to yourself, boy, I think I've seen this before, and I would get theta equals, it's about 6.9 degrees. Yeah, we've worked with this. Algebra 1, Algebra 2, and in between there we did geometry. So that's why we buzzed through this fairly swiftly. You've seen it before. Hopefully it's coming back to you. There you go. You can now work on your finish your 4.1 homework and do your 4.2 homework. Good talk.